Well, good morning. Been a while, so been very busy, and then stuff at work. Anyway, I finally got a chance to take a look at my 89028. What I was having was a problem with the power supply. It wouldn't turn on. The fan would run, but you wouldn't hear the device actually power up. And then the DEFPOM did his repair of an 8901. Now the 8901 and the 8902 share a lot of the same componentry, so I thought it was great. He was having a problem with the power supply, and so what I did is watched his repair, and I thought, well, excellent. You know, I can go in, take a look at mine, and use some of the troubleshooting learnings that he took. Anyway, it wasn't working. I took it out, dropped it on the bench, and now when I turn it on, you'll see that the power supply comes on and you can hear the unit power up and the fan go and all that sort of thing. Now, this was a bit annoying because I'm like, oh, well, bugger, you know, I've got the unit out and it wasn't working. And then as soon as I put it on the bench and took the covers off, bam, it started working again. So I started drilling into what the issue was, and what I found is quite interesting. So what we want to do is take a look at the schematic. I'm going to turn that off, and then we'll zoom in on the schematic and we'll see how that goes. So here we have the basic schematic from where the mains power comes in, goes through the rectifiers, then goes through the regulators, and is applied to the unit. Now, these little things that I've circled in gold are the three of the test points that I wanted to take a look at. And so I turned the unit on and I started taking a look to see what was going on here in terms of the power. And I noticed that I wasn't getting any power at all down here. Now, I was getting my 15 volt unregulated, and I was getting the 15 volt regulated. It took a little longer to find that than I expected, because it turns out the LED in this unit is actually blown as well. So that led me astray. Anyway, I got the power supply out on an extender card and started probing around. Now, that was a little bit of a, you know, I was wondering why I wasn't getting the power there. And I started working my way back. And what I finally noticed, it took a bit of while, what I finally noticed is that if we look over here, this is the motherboard that the power supply plugs into. And there is a relay right here. Now, that relay takes the 15 volt regulated and then sends it back down to the rest of the regulation circuit so that you can get your negative voltage rails. So without that relay working, then I wasn't going to get any power. So let's just flip over and take a little bit of a look closer. And so what we can see here is up here we have the 15 volt unswitched, and that comes in, and that 15 volt unswitched appears on the oven controlled oscillator. I happen to have that oven controlled oscillator on the, oh, my other camera's turning off. I happen to have that oven controlled oscillator option in this machine here. And this is when I started looking to see, okay, well, why is 15 volt unswitched great, but I'm not getting 15 volt switched? Well, the reason is the reason it's called switched, no surprise, is that it gets switched on by this relay. And that relay then puts the 15 volt back into the rest of the regulator so that you can get your minus 15, your plus 15 switched, and that can come out to the rest of the motherboard. And if we take a look over here, you can see that the 115 volt lines come in and go through the relay. So basically, when you turn the switch on, that energizes the relay, and then that will do the switch here so that you get your switched power. It's a pretty simple design, but what it meant was when I tested it and so on, I discovered that it looked like the relay might have had a dry joint on it. So I resoldered the relay back in. I fixed the joints up, and then I left it running for a while. And what I was finding was that I thought it was fixed, but a day or so later I had the exact same problem. So what I think the issue is that this relay here, it's just getting caught. There might be a little bit of corrosion or something on the contacts. So when you try and turn it on, it's not switching, and that's causing the problem. So let's take that board out and we'll have a look at it. Okay, so here is the power supply section. I've taken off the little plastic cover so that we can maybe get a look in there without any reflections. Drink of the day is a nice Bloody Mary. And here you can see this is the main transformer. This is the oven controlled oscillator. This is the regulator board up here. We have our power supply caps. This goes to the pass transistors, which are on the back of the unit. And if we zoom right in there, let me see if I can get, where is it? Let me see if I can see it. Should be right there. You can see just here, this is the little relay. Now that's a 110 volt relay. So if we just swing the unit around, what you'll see here is this is the bottom of the motherboard there for the power supply. And you'll see this little cover, and this is covering the bottom of the relay. So the relay connects in there, and if we take that little cover off, I have the unit unplugged, so we can safely get in there. Now we'll see that's the relay in there, and this is going to be the power, the 115 volt that is coming to that relay to switch it on. And then down here is where the oven controlled oscillator is, and that power comes in. So what I'm going to need to do is to unsolder this relay, and then we'll see if we can get the top off and clean inside it. So we'll be back shortly. Okay, so I have my little FR300. So let's start unsoldering that. Let's see if I can get it. Okay, so let's see if we can get in there and get that relay out. Oh, it is much looser now. There we go. Okay, so here we can see the little relay. Well, get it in front of the camera. And so let's get under the overhead and we'll see how that looks. Okay, so there's our there's a little relay, and you can see that it is a very interesting relay in the sense that the pin layout is not like current model pin layouts, but it is 125 volt, 24 volt DC relay. So looks like, if we look just in there, you'll see like a little dimple. So what I'm hoping is that's just a little, it's just a little friction push on it, and it'll pop off. That's not an ultrasonic weld. So let's zoom back out again, and we'll take a look and see if we can get in there in some method. No, actually now, so if we come down and have a look, let's zoom in again. Let's see if we can get, looks like that's actually some form of potted compound that it's pushed in there, because that looks very much like, you know, if you have a look through there, you can see where it's come up the sides a little bit and so on. So I'm going to have to go away and take a little bit of a poke at this and see what happens. That said, you know, we now have the number for the relay. So even though it had a HP specific part, we might be able to find if this relay or a similar one will work. So let's go take a look at that, and I'll be back in a minute. So I looked it up, and sure enough, the part is still available. It's a Panasonic relay. So now, if you remember, the number was NC2ED, and if we look down here at the ordering information, NC part 2 is a form C, so it's NC-ED. These have an EB, so they're standard amber sealed. I'm guessing that's what that is. P will be for the PC board plug-in style. Then the coil voltage, DC 24 volt. So this should be this should be able to be used and put in the replacement. So if we take a look here, here is the, this is going to be the appropriate footprint. And so let's take a look, let's zoom in a bit and see if we can see the, get in on there. And so what we can see is that pins 11 and 12 go to pin 7, which is what we see here. 4 and 5, 4 is the negative, so that's the coil. Then 13 and 14 go to 2. So the same schematic from the bottom view is going to be the same. So if we look at that, that's basically the view that we're going to get. So it looks, you know, pretty much, looks like we're going to get, be able to just buy this one and use it as a replacement if I can't get the top off that. Let me just make sure there isn't a better one anywhere. Oh. Sockets. Okay, let's have a little poke around and see if we can get into the unit. But at least now I know I can get a replacement if we screw this up. Or I mean me. Anyway, let's zoom out and see what is going on. Okay, well, fortunately, I have a replacement, or I know where I can get a replacement, because if we look right in, I think what you'll see right in there is you can see there the coil wires are actually inside those little blocks, and I've cut one while I was trying to get that case off. So the coil is now open circuit. There's no point in continuing on and trying this, so I'm going to go order a replacement part, and we'll see how it goes. Anyway, hope you'll join me for part 2 of this, and we'll swap in a replacement relay and get the 8902A working correctly. Anyway, catch you later. Thanks. Bye.